Okay, Bismillahirrahmanirrahim. Assalamualaikum. Hi everyone. Okay, today we're going to continue with the chapter 2, which is analysis of statistical determinate trusses. Okay, so we already know how to determine the statically determinate trusses in the previous chapter. Okay, so this is our learning outcome at the end of this chapter. So you guys should able to first classify the types of the plane trusses, calculate the internal forces of member using the method of join. Okay, then you guys should able to identify the zero force member. Fourth is able to calculate the internal forces of member using the method of section. And lastly is calculate the internal forces by using the inspection method. Okay. So, as the application, okay, truss are commonly used to support a roof. Okay, so truss memang basically kita memang guna dia dekat roof ataupun bridges. Okay, for a given truss geometry and load, how can we determine the forces in the truss member and select their size? Okay, ni yang kita akan maksudnya kita kena analyze the internal forces. Okay, and more challenging question is that for a given load, how can we design the trusses geometry to minimize the cost? Of course, we don't want to make a design or propose a design that will have a higher cost. Okay. Okay, this is one more example of the truss. Okay, trusses are also used in a variety of structure like a crane, frame of aircraft or space station. So ni juga pakai ataupun we applied the truss structure. Okay, how can we design a lightweight structure that will meet load, safety and cost specification? So those are the questions that coming in order we learn about this topic. Okay, so as for the introduction, what is truss? Okay, the truss is a assembly of a straight member connected by their end by flexible connection to form a rigid triangular configuration. So dia adalah terdiri daripada a straight member connected by flexible connection, okay, in order to make a rigid triangular. Okay, so a modern truss are constructed by connecting a member which is usually consists of structural steel or aluminium shape or wood strut to gusset plate by bolt or welded connection. So this is the example of the gusset plate. Okay, it is commonly used in the truss structure. Okay, if all member of a truss and the applied load lie in a single plane, okay, if the member and also the applied load lie in a single plane, the truss called as a plane truss. So this is the common configuration of bridge and roof trusses. For example, in this case is for the roof trusses. So this is some of the example with the name. This is the whole truss, spread truss. Okay, for the roof trusses. Okay, fan trusses, 3-hinge arch trusses. Okay, and this is the common configuration of the bridge trusses. So the previous one is the for the roof trusses, and this one is for the bridge trusses. Okay, this is the Pratt trusses, Ho trusses, Warren, Parker, so K trusses. So basically, for your project, also you will use this kind of idea, how to make your bridge. Okay, so you guys boleh dapatkan idea lah macam mana nak design you punya bridge for the project. Sama ada nak combine, nak guna pred ke, hoe ke, ataupun nak combine ke, it depend on you guys. Okay, so classification of the plain truss. Okay, there are few types, not the types, how we classified the truss. Okay, for a simple truss, which is the simplest form of rigid and stable truss, is a triangular. Okay, so kalau empat segi itu tidaklah stable. Okay, so the simplest form of the rigid and stable truss must be a triangle. Okay, triangle. So this is the more stable truss. Okay, and by adding two elements and a joint or knot to the basic triangle, as shown here, will make this truss called as a simple trusses. So this is a simplest form of the trusses. Okay, so they make a joint here, new joint, and also the two new member. So this will become a simple truss, and so on. So if you have a few of the simple truss, so it will become a simple truss. But you need to connect like this lah. So new member, two new member with a new joint. So if you have more, add two more new member and one joint here, and it will become a simple truss. Okay. Other than simple truss, okay, this is also the simple truss. So we have this one, and we add a new member here, AD and BD, and also a joint here. So this will become a simple truss. Okay, other than simple truss, we call as a compound truss. Okay, a compound truss is formed by connecting two or more simple truss. Okay, as shown in this figure. So we can see here that the truss ABC and CED is a simple truss. So they are connecting by a common joint C and also a member BE. So this is called as a compound truss. Okay, this is one more example. Okay, so two simple truss, which is ABC and DEF, okay, is connecting by a member CD and also BF and also BD. So this also an example of the compound truss. Okay, so simple truss. So the connecting of two or more simple truss will become a compound truss. Next is a complex truss. Okay, a complex truss use a general layout of a member different from that used in the simple and compound truss. It is often incorporate overlapping member as shown here. So we have the overlapping member, but these types of trusses will not be covered in this module. Okay, so the analysis of the statically determinate trusses. Okay, basically the force that act on a member in a simple truss, either axial compression or tension. Okay, so maksudnya dekat trusses memang dekat member dia hanya akan acting sebagai tension or compression. So kalau tension maksudnya dia akan keluar. Okay, pulling out. So the sign convention adopted to indicate ties, which is tension member, and strut compression member is shown here. So kalau di dalam compress strut, this is compression member, so kita akan nampak anak panah dia akan ke dalam. This is joint, So dia akan bagi anak panah dia ke dalam, okay, ke arah join. Whereby for the tension member, the arrow will go out from the join. Dia akan mengarah ke luar daripada join. Okay. And before we go for analyze, truss analyze, the truss has been to classified first, whether it is statically determinate or indeterminate as mentioned in chapter 1. So we already learned how to classify whether the truss is indeterminate or determinate in the chapter 1. So if it is statically determinate truss, the following method can be employed in order to solve the internal forces. So kita ingat dalam bab ini sebenarnya kita nak solvekan, kita nak cari value for the internal forces. Maksudnya value dekat member-member tu dia carry berapa force. Adakah dia mengalami compression ataupun dia mengalami tension. So we need to solve it, the internal forces of the truss. So there are 3 methods here, which is the first one is the method of join, then method of section, and lastly is the method of inspection. Okay. Okay. Dan ada lagi satu point kat sini yang kita kena tahu, how to determine the zero force member. Okay. So at first, we will go for the method of join, which is I will explain in detail in the next video. Okay. Okay. For analyze the truss, we make some assumption. Okay. So the assumption that we made is all load are applied at join. Okay, so load memang hanya akan di-apply pada join. Takkan ada load di tengah-tengah member. Okay, so all load must be applied at the join. Okay, sama ada dekat join yang ini ataupun dekat support pun boleh. Tapi yang mana dia hanya akan ada di join. Tidak akan jadi load dikenakan at the middle of member. So the load only applied at the join. Okay, and the member are joined together by a smooth pin. So this assumption is satisfied in most practical cases where the joint are formed by bolting or welding. Okay, so with these two assumptions, the member act as a two forces member, which is they are loaded either in tension or compression. Okay, so maksudnya dekat member tu akan mengalami sama ada dia akan mengalami compression ataupun tension. So there are only two ways of forces acting on the member, which is dia akan bertindak sebagai tension, dia akan mengalami tension forces ataupun dia akan mengalami compression forces. Okay, so I guess for the next video, I'm gonna explain detail on the method of join. Okay, so bear in mind that loads only apply at the joint, and also all members are connected only at their end by frictionless hinge in the plain trusses. Okay, so I guess that's all for this in this video. So we're going to continue with the method of join in the next video. Okay, okay, that's all. Assalamualaikum. Thank you.